Hello, I am Sunita. Welcome to my class. Here I am going to discuss Karnataka DET science topics according to the syllabus. Here the topic is electricity. This is the second class. This is the part 2 in electricity. Resistor in series. When two or more resistors are connected end to end, the arrangement is called as a series combination. Look at here. Here you are having three resistors. Here each resistor connected to end. This arrangement we will call it as a series combination. Then here ammeter is used to measure a current. Always you have to connect a ammeter in series only when you are measuring a current. That point is very important. That one you have to remember. Then here one more important point, voltmeter is used to measure a volt. This voltmeter is connected to parallel in a circuit, parallel across the resistor in a circuit. Then you can easily measure the voltage in a particular resistor. Then when you connect resistor in series, then two important point you have to remember. Current through each resistor is same. Here when you connect the resistor in series, the current in each resistor will be same. First resistor also I, second one also I, third one also I. Throughout the resistor, current will be same. Then equivalent resistance is larger than the largest individual resistor. This we have to verify. Let us discuss here. According to the Ohm's law, V is equal to IR. For substituting this one for each resistor, you will get V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3. Here, in each resistor, current will be same when you connect the resistor in series. Then here one more important thing, total voltage it will be equal to sum of the voltage drops. Therefore, sum of the voltage means V1, V2, V3, it will be equal to V. If you add these three equations, V1, V2, V3, it will be equal to I into R1 plus I into R2 plus I into R3. You can substitute V1, V2, V3 into V, then you will get V, it will be equal to IR1 plus IR2 plus IR3. Then here, you know according to Ohm's law, V is equal to IR. Then V, it will be in place of V, you can write it as I into R. Then here if you take I as a common, you will get R1 plus R2 plus R3. Then here both the side you are having I as a common, I it will get cancelled. Then R it will be equal to R1 plus R2 plus R3. This it will verify this statement. Equivalent resistance or sum of the resistance it will be larger than the largest individual resistance. If you add all the three resistance, then you will get total resistance or resultant resistance. Therefore, when you connected the resistor in series, RS it will be equal to R1 plus R2 plus R3. This one it is very important. Then this is the formula we will use when you are calculating resistor if you are connected in a series combination. Next one, resistor in parallel. Here observe here. Here we are considering three resistor connected in a parallel combination. Then here also we will use voltmeter. It is connected in parallel. We can measure the voltage in a particular resistor. Then here ammeter is used to measure a current. Ammeter is connected in a series in a circuit. Then here when you connect the resistor in a parallel, voltage across each resistor is same and equal to the applied voltage. Voltage across each resistor it will be equal to applied voltage in the case of a parallel resistor. Therefore, current in each resistor it will be different, but voltage will be same. Then resistor in each resistor it will be different. Then according to the equation, total current is equal to the sum of the current through the individual resistor. Total current it will be equal to sum of the current in the individual resistor. Therefore, I it will be equal to I1 plus I2 plus I3. Substitute Ohm's law, I it will be equal to V by R. Then here I1 it will be equal to V by R1 plus I2 it will be equal to V by R2, I3 it will be equal to V by R3. Here V is constant because voltage across each resistor is same and equal to the applied voltage. Then here if you consider V as a common, then you will get 1 by R1 plus 1 by R2 plus 1 by R3, and this V and this common V it will get cancelled. Then you will get 1 by RP, it will be equal to 1 by R1 plus 1 by R2 plus 1 by R3. Reciprocal of equivalent resistance is equal to the sum of the reciprocal of individual resistor. This is valid in the case of a resistor when you connected in a parallel combination. Equivalent resistance is less than the value of the smallest individual resistance in the combination. This equivalent resistance it will be less compared to the sum of the individual resistance. Therefore, according to the resistor, when you connect it in parallel combination, then this is the formula we will use to calculate the resistance in a particular parallel combination. Here, reciprocal of equivalent resistance is equal to the sum of the reciprocal of individual resistance. That one you have to remember. Advantage of parallel combination over series combination. Parallel combination will be better compared to series combination. How? Let us discuss here. First one, series circuit. When one component fails, the circuit is broken, none of the component work. In series circuit, the components they will be connected in series. If one component fails, then the current it will not pass to second component. Then automatically the remaining components they are connected in series, they will get filled, they will not get any current further, then they will not work properly. Then the second one, different appliances have different requirement of current. This cannot be satisfied in series as current remains same. You know, in series combination the current in all the three resistor it will be same, but according to our convenient we will use so many equipment like fridge, TV, washing machine, like that. Then here you can observe each component it will require different amount of current, but in the series the current will be same in all the components. Then you are not able to change any current in any one particular appliances. But in the case of a parallel combination you can vary the current. Then according to your convenience you can connect particular component with a particular requirement of current. Therefore, in this way series combination is not good compared to parallel when you are connecting components in the series combination. Parallel will be the good one. The next one, third one, the total resistance in a parallel circuit it will be decrease. You know, the total resistance in the parallel circuit it will be decreases according to sum of the remaining resistor connected in parallel combination. If total resistance is decreased means the opposition of electric charges. Resistance is nothing but opposing the flow of electric charges. If it is decreased, then current it can easily pass through a circuit. Then if the total resistance is decreased, then the component it will work with a very high current and also with very high voltage. Then it will be good for our appliances. In this way, the parallel combination is more convenient compared to series combination. Heating effect of electric circuit. If an electric circuit is purely resistive, the source of energy continuously gets dissipated entirely in the form of a heat. It is known as heating effect of electric current. You can observe in your home if you are using any electrical instrument or appliances for a long time, then if you touch the appliances you will feel heat. This is nothing but heating effect of electric circuit. This is given by the formula E it will be equal to P into T. This it will be directly proportional to VIT. Then E it will be equal to H. heat produced, then if you replace E by H, then H it will be equal to VIT. According to Ohm's law, V is equal to IR. If you substitute this one in the place of a V, then I into I, it will become I square RT. Then H is equal to I square RT is the heating effect of electric circuit. Joule's law of heating effect of electric current, it states that heat produced in a resistor is directly proportional to the square of current. H, it will be directly proportional to the square of the current. Then H is directly proportional to the resistance for a given current. H, it will be directly proportional to the resistance of a given current. It is directly proportional to the time for which the current flow through the conductor. H, it will be directly proportional to T. Then H, it will be equal to I square RT. Heating effect of electric current, it will be directly proportional to square of the current. Then it will be directly proportional to resistance of a particular conductor. Then it will be directly proportional to time for which the current flows through the conductor. This one you have to remember. Heating effect is desirable in device like electric heater, electric iron, electric bulb, electric fuse. Heating effect you can observe, otherwise you can feel. We can use in the case of a electric heater, electric iron, electric bulb, electric fuse. Heating effect is undesirable in device like computers, computer monitors, TV, refrigerator, etc. Here heating effect is there, but heating effect it will be negligible in the case of computers, computer monitors, TV, refrigerator. But heating effect we can use as a plus point, otherwise we can use in a device like electric heater. Heating effect we will use to heat the water. Electric iron, this heating effect we will use to press the ironing the cloth. Then electric bulb, electric fuse, you can use in the electric fuse also when high electricity, otherwise high voltage is passed in an electric circuit. Then electric fuse it will get disconnected, then it will stop the flow of high voltage in an good electrical appliances, otherwise it can prevent the damage of an electrical appliances. Electric bulb, but in the case of an electric bulb, most of the power consumed by the filament appear as a heat, and a small part of it is radiated in the form of a light. Here also it will produce the heating effect, then small part of it is radiated in the form of a light. This is the heating effect of electric current. Filament of electric bulb is made up of tungsten. In an electric bulb, the filament is made up of a tungsten. What is the reason why it is made up of a tungsten only? Here, it does not oxidize readily at very high temperature. Even if high voltage is passed in the filament also, it will not get oxidized. The next one, it has high melting point, 3380 degrees Celsius. It has very high melting point. Only if it is reached this melting point, then only it will start melting. Therefore, because of this high melting point, we will use filament like tungsten. Then this bulb are filled with chemically inactive gases like nitrogen and argon to prolong the life of a filament. Then the bulb is filled with inactive gases like inert gases like nitrogen, argon, because inactive gases means it will not react with any other components, and it will increase the life of a filament. That is the purpose we will use nitrogen and argon to prolong the life of a filament. Electric fuse, it is a safety device that protect our electrical appliances in case of short circuit or overloading. Fuse, it is a very safety device. Electric fuse, we will use this to protect electrical appliances when high voltage or short circuit happens. Then the fuse itself it will get melted, then it will stop the connectivity of current with any other electrical appliances. Then fuse is made up of pure tin and alloy of copper and tin. Pure is made up of an alloy. Alloy is a very strong. Then if high voltage, otherwise short circuit happens, then this alloy it will start melting, then it will stop the connectivity of electric current in the another electrical appliances. Then fuse is always connected in series with live wire, because if it is connected in series, if high voltage or short circuit happens, then it will disconnect the electricity. If it is connected in series, if first appliances is disconnected, then automatically current it will not flows through the remaining electrical appliances, then it will cut off the flow of the current. The next one, fuse has low melting point. Fuse it has a low melting point, that's why it will melt very fastly if overloading or otherwise any short circuit happens. Current capacity of fuse is slightly higher than that of an electrical appliances. This current capacity it will be slightly higher, that's why it will get disconnected if high overloading or short circuit it will happens. That is the help of the fuse. Normally in the every homes we will use electrical fuse. It will protect the remaining electrical appliances when any short circuit or overloading happens. Electric power, the rate at which electrical energy is consumed or dissipated in an electric circuit. Electric power is nothing but how much energy is consumed or dissipated in an electric circuit. We will call it as a electric power. P it will be equal to VI, then P it will be equal to I square R, it will be equal to V square by R. The SI unit of power is watt. 1 watt it will be equal to 1 volt into 1 ampere. The commercial unit of electrical energy is kilowatt hour, kWh. 1 kilowatt hour it will be equal to 3.6 into 10 to the power of 6 joule. 1 kilowatt hour it will be equal to 1 unit of energy, electrical energy released or dissipated in an electric circuit. Electrical resistance problems. First one, in an electric circuit, a current of 6 ampere is flowing through a resistor. The voltage drop from one end of the resistor to the another is 150 volt. What is the value of the resistance? Solution here, you know that the current and voltage drop across the conductor. Across the conductor, current and voltage which will be vary. Hence, we can use the Ohm's law to find the resistance as follows. R it will be equal to V by Y, V by I according to Ohm's law. Then R it will be equal to, they given the voltage. Voltage is 150 volt. Therefore, in the case of V, substitute 150 divided by I. The current is 6 ampere. Therefore, 6 ampere. Substitute these two values, then you cancel. You will get 25 ohms. The resistance of the resistant in the circuit is 25 ohms. Next problem, a wire of length 3 meter, length is 3 meter, area of cross section A is 1.7 into 10 to the power of minus 6 meter square, has a resistance R 3 into 10 to the power of minus 2 ohm. First question, what is the formula for resistivity of the wire? Then what is its units? Question number B, calculate the resistivity of the wire. Solution, resistivity of the wire is given by the formula rho. It will be equal to capital R A divided by L. Here rho is the resistivity, R means resistance, A means area of cross section, L means length of the wire. Then its unit is, SI unit is ohm meter. Then next one, if you want to calculate resistivity, you have to use this formula. Rho it will be equal to R into A divided by L. You know R it will be 3 into 10 to the power of minus 2 ohms. Then area of cross section here 1.7 into 10 to the power of minus 6 meter square. Then length is 3 meter. If you substitute all the three values in this formula, substitute, then if you simplify, you will get the answer. Rho it will be equal to 1.7 into 10 to the power of minus 8 ohm meter. This is the very important formula you have to remember. Resistivity of the wire, rho it will be equal to R into A divided by L, and its units is ohm meter. An electric motor takes 5 ampere from A 220 volt line determine the power of the motor and energy consumed in 2 hours. Here the electric motor is working. It is consuming 5 ampere of current from 220 volt. Here they are asking to calculate the power of the motor, then energy consumed by the motor in 2 hours. You know the formula for power is power, it will be equal to voltage into current. Here they are given the voltage 220 volt and also current 5 ampere. Substitute these value in this equation. P, it will be equal to voltage 220 into current is 5 ampere. Multiply these two values, you will get 1100 watts. The SI unit of power is watts. The next one, you have to calculate the energy consumed by the motor in 2 hours. Energy, it will be equal to power into time. Already you calculate power. Power is nothing, power is 1100 into time is 2 hours, but here hours you have to convert in terms of a second. Then 1 hour, it will be equal to 3600 second. Then you are calculating for 2 hours. Multiply this value with 2, then you will get 2 hours in terms of a second. If you multiply all, you will get this value. Then if you want to substitute in terms of a 10 powers, then 3.96 into 10 to the power of 6 joules. This 10 to the power of 6 you can split into 10 to the power of 3 into 10 to the power of 3. 1 10 to the power of 3, it will be equal to kilo. Kilo is nothing but 10 to the power of 3. Therefore, the final answer is 1.96 into 10 to the power of 3 kilojoules. Here the power consumed by a motor is 1100 watts. Then energy consumed by a motor in 2 hours is 3.96 into 10 to the power of 3 kilojoules. Thanks for listening my class. Send me your valuable feedback. Thank you.